Good morning students. Today we start and learn about the alternative sources of energy. Okay. Alternative sources of energy means what? Conventional sources of energy or renewable sources of energy which we get unlimited and which we get again and again from the nature, okay, from the universe. Now the first one is the solar energy. So India is fortunate to receive solar energy for greater part of the year. By solar energy we mean the light and heat energy which falls on the earth. So India, every day almost we get the solar energy from the sun. So sun is a huge source of energy. Huge means big source of energy. Solar energy is very different from the conventional sources of energy. Okay, I already told the conventional sources of energy. And the electrical energy can be generated by direct conversion of solar energy. By converting, that means by changing the solar energy into electric energy, we can get easily. So here solar heating devices. How the solar heat, which one will be absorbing the heat very fast? Which absorbs the heat very fast? Mostly the color black. Okay, so that is why solar panels when we see, or solar cooker and everything is painted by the black. Okay, so through that it will be absorbing the more heat. Okay, now I will explain to you about the solar cooker. Okay, so here is enough explanation in your textbook. You can read on your own. Also you post the video, you can see the video. Okay, so solar cooker from 2 to 3 hours it can absorb 100 to 140 degrees Celsius heat. Okay, so this heat is very much useful and enough to cook the food. With this we can cook the rice, pulses, edible foods means some useful foods, vegetables inside the black pots. Okay.
Solar cooker. A solar cooker is a device that is used to cook food by utilizing the energy radiated by the sun. Here you can see how a solar cooker is made. You may require a wooden box having a thermocol lining, aluminium sheet, black paint, mirror, glass sheet, hinges, wooden lid for the box, and containers to cook food. Take a wooden box having thermocol lining from inside. Now make a box out of the aluminium sheet. Paint the inner side of the aluminium box black. Now fix a mirror to the lid and with the help of the hinges, fix the lid to the wooden box. Now cover the box with a glass sheet. The glass sheet helps in trapping the heat radiations. The mirror helps in concentrating light rays into the box. Now this solar cooker can be used to cook food. Paint the containers in which you wish to cook black from outside. Place these containers filled with food item inside the box. Now place the solar cooker in direct sunlight. Adjust the position of the plane mirror so that a strong beam of sunlight falls on the glass sheet. The rays coming from the sun pass through the glass sheet and are absorbed by the objects inside the cooker. The glass sheet does not allow the solar energy to flow out in the form of radiant heat. Gradually, more and more heat radiations get trapped and the food gets cooked. The range of temperature that can be attained in this type of cooker is 100 to 140 degrees Celsius.
The most commonly used renewable energy source is solar energy. But how is solar energy used to generate electricity? A photovoltaic or PV system is used to convert the solar or light energy into electrical energy. The basic component of the PV system is known as the solar cell. A single solar cell has the capacity of producing about 0.5 volts of electricity. A solar panel or solar module is the combination of several solar cells connected in series to generate usable voltage. The solar panel voltage can be increased by increasing the number of solar cells. For example, 30 solar cells connected in series will produce an output of 15 volts. A combination of solar panels connected together is known as solar array and can be used to achieve required current and voltage. How does the solar cell work? The generation of electricity on exposure to sunlight is known as the photovoltaic effect. This principle is used by solar cells to produce electricity. The solar cells are made up of semiconductors, mainly silicon, and comprises 3 layers. The top layer, called the N-type layer, is comparatively thin and contains high concentration of electrons. The bottom layer, called the P-type layer, contains high concentration of holes. When the P-type and the N-type semiconductor is joined, it forms a p-n junction. On forming a p-n junction, the electrons of the N-type material try to reach the p region, creating a negatively charged layer. Similarly, the holes of the p-type material try to reach the N region, creating a positively charged layer. This region between the 2 layers is known as the depletion region of the semiconductor. Sunlight penetrates the top thin layer easily to reach the depletion region. Due to the deficiency of charge in the depletion region, it contains neutral atoms. These neutral atoms are broken when the photons from the sunlight strike the depletion layer. This knocks the electrons from the neutral atoms, leaving behind the holes and producing free charge carriers. Then, the electrons move towards the N-type layer and the holes move towards the P-type layer due to the electric field present in the depletion region. On connecting an electronic circuit, the electrons flow through it, generating electricity to electrical devices like bulb, fan, etc. Please subscribe our channel and join with us. Thank you. Let's grow up. Never stop your learning.
Then silicon, which is used for making the solar cells and is abundant in nature, but availability of the special grade silicon for making solars is limited. Okay, so the solar cells are made up of silicon. We can get abundant in nature, but okay, the special grade silicon for making the solar cells is limited. Okay, so for example, the whole universe is, our land is full of water, availability of water more is there, seas, oceans, but the fresh water is only some amount only what we can use for drinking and using. So like that only silicon we can get more in the atmosphere, but it is we can available which we can use for making the solar cells is very limited. Okay, so the next one, okay, so in spite of high cost, that means though it is a high cost, low efficiency, solar cells are used for scientific and technological applications. So solar cells, not only for the solar panels, in so many places they use the solar cells. So what are the cells? Uses are here. The first one is artificial satellites and space probes like Mars orbiters use solar cells as the main source of energy. Then radio or wireless transmission systems, that means without wire what we use, the transmission systems, or TV relay stations in remote locations use solar cell panels. In some places, in remote villages, in mountain areas where the electricity is not possible always, they use the solar panels. Okay, and the next one is the where we use for the traffic signal. Okay, so traffic signals, calculators and many toys are fitted with solar cells. The solar cell panels are mounted and specially designed in inclined rooftops so that more solar energy is incident over it. The domestic use of solar cells is, however, limited due to the high cost. Because of the high cost of the solar panels and silicon, okay, so limited amount only is used.
The principle behind the wind turbines is very simple.
If you watching this video, don't forget to share your comment and help us to spread globally. Let's grow up, never stop your learning.
The energy in the wind turns the blades around a rotor. The rotor is connected to the shaft, which spins a generator to create electricity. In this video, we will learn how a wind turbine works and generate electricity. A wind turbine has many components which collectively help in generating electricity. The wind runs through the turbine blades, thus decreasing the air pressure on one side of the blade. This causes a difference in air pressure through both sides of the blade, creating a force on the blade. The intensity of the force rotates the rotor, but the slow rotation speed of the blades is not enough to produce electricity. For this reason, a gearbox is connected between the rotor and the generator. This generator transforms the aerodynamic force into electricity. The housing holding the gearbox and the generator is called the nacelle, which can move according to the direction of the wind. If the direction of the wind changes, a velocity sensor located on the top of the nacelle sends a signal to the yawing mechanism at the base of the nacelle. This mechanism then moves the blades to face the proper wind direction. Also, the blades can rotate using a blade tilting mechanism to align itself with the proper angle of the wing. In this way, wind turbines can convert wind energy into electricity. To learn more about renewable energy, check out our other videos.